Okay. Can you listen to me now?
Yes, sir. শোনা যাচ্ছে।
So we'll start with today's class. Now, biomedical signal processing. Okay, so far we have seen how to work with images, different imaging modalities. We have seen how to work with different biomedical images. Okay. Now we have seen the signal processing part, like image processing part, how to work with images and how to process those images. We have seen some techniques and other things. And we also see how to actually model those things using deep learning techniques, more recent, more recent inventions like this way. Acha. Now we'll start with our biological signals now, not images, but signals. Okay. Signals related to some of the biological activity. Okay. Signals related to some biological activity. We have different activities in the body, and we can actually measure those activities through some ways. For instance, our heartbeat. So the activity of the heart, okay, the electrical activity of the heart, we can actually measure it, and that corresponds to the ECG. Okay, you are already familiar with those things. Also, then we have electrocardiography or cardiogram, okay, electrical activity of the heart. We have brain activity. Okay, we can record it. It responds to EEG, electroencephalography. Then some muscle activity. Muscle means, like, for instance, your breathing. Breathing is a muscle function. Okay, so it corresponds to EMG, electromyogram. Okay, there are like around 10 different types of activities measurements we can actually do. EGG. Okay, EGG. There are many things. We'll talk about those things later towards the end. So these are different biological activities that we have that we can actually measure from our body, and we can record it through some record them through some external, like electrodes. Through some external electrodes, we can place the electrodes on the outside of our body, on our skin, electrodes on the screen, and we can measure the electrical activity. Okay, we are measuring the electrical activity. Some potential difference is there, some potential, due to some potential difference, some activities, these activities occur due to some potential difference. We can actually measure them. We'll talk about it later, a little bit later, more details. So through this measurement, we can actually see how our heart beats. For instance, we have already seen these things in different it's like, so this is like a common type of heartbeat. Okay, ECG. ECG measurements look something like this. It has a peak here. Okay, and if a person dies, this peak gets flattened out. So this is like ECG measurement. So what we do is that by keeping track of these things, by keeping track of this electrical activity of the heart, we can see whether the heart is functioning correctly, properly or not. Okay. Any abnormalities, any abnormalities, we know what is the standard. We know what is the standard ECG should look like. We have this idea. Okay. We know what a standard ECG should look like. So any abnormalities in the ECG can correspond to some of the diseases. Okay, some diseases, some other functions. By measuring that difference, so from the standard ECG, what kind of difference there is, the abnormality, we can identify some of the diseases. We can identify them. We can understand the condition of the patient from those things. Okay, so based on that, we can actually perform, take the necessary measurement to actually give the patient some medical medicine, things like that. So this is the actual purpose of signal, biological signal processing, biomedical signal processing. So we'll look at some of the main ones like ECG, EEG. These are the main ones. We'll try to look at it. Any questions from now? Any question?
No, sir.
Achha. So you see, these signals will follow this way. First, we need to understand the process, understand the biological process. Okay. Without understanding the biological process, We will not be able to understand how we can measure it. So understand the biological process, then how measure it. We'll see how we can measure it. Okay. Then here, just like image processing, you have image processing. Similarly, you have some signal processing there. Okay. Signal processing is also there, biological signal processing. For instance, when you are keeping this, taking these readings from the electrical activity, you amplify the signal. Amplify the signal so that you can have a more clear reading. And when you amplify the signal, noise is also sometimes amplified. So you have to use some filters to remove the noises. So there are some signal processing is there. Just like for images, you have some image processing techniques. Similarly, when you are recording these signals, there are some signal processing activities are there. We'll also discuss it, inshallah. After the signal processing, you can signal it, you can actually understand it. So understand the reading. So understand the readings. What a understand the readings. What a standard signal, like what a standard ECG should look like. Okay. Once you have this understanding, then what are the different abnormalities can occur? What are different abnormalities that can occur in the signals? And based on that, how to determine, how to, you can say, quantify those abnormalities, how to quantify them. Okay. How to quantify those abnormalities. Okay, there are different signal processing techniques through which it can be time domain techniques, how to quantify them. It can be in the time domain, it can be in the frequency domain. There are wavelet transform, other different transform, other techniques to actually identify and measure this abnormality. Based on that, you can actually take necessary actions. So this is the process that we are trying to follow. We'll try to follow. Now, okay, let's start with our first one. We'll start with ECG. ECG is the most common. ECG. Okay, ECG is the most common, so we'll start with this one. Now, ECG stands for electrocardiogram. Okay, this electro means an electrical signal. Electro means the electrical signal. The cardio means the heart. Okay, and the gram means some kind of recording. Okay, so ECG actually is the recording of the electrical activity of the heart. Activity. So ECG is the electrical activity of the heart. Okay, we can record it, we can understand it. And based on these things, we can perform different diagnostics of heart. Okay. Now, to understand this ECG, how we actually measure it, first we'll have to start with this one. We have to understand the biological process. Okay. We need to understand how our heart function. Okay. It is very important to understand it. Otherwise, you will not understand what different ECG is, what are the abnormalities. So we need to understand how the heart functions. Okay. Now I'll give you some brief idea so that you can actually understand properly the process. You don't have to go into very deep. It can be you can go into very deep. We don't need very deep, but we just need to understand the overall process so that you can actually track everything what is happening there. I'll also share some videos that will make YouTube videos I have downloaded. You can also see those things. It will make things even more clear. Acha, let's try to understand some of these things. Heart functions. তোমাদের কি ল্যাব হয়েছে? ল্যাব 5 হয়েছে? আচ্ছা, in your lab 5 is based on this ECG. Okay. Shofi, I think will take this lab. So এটা যেহেতু হয়ে যাচ্ছে তোমাদের সুবিধা হবে বুঝতে। আচ্ছা। Now, just to give you some of the different parts of the heart. First, let's try to understand different parts of the heart. First, you have the cardiac muscle. Okay. The cardiac muscle, this is actually responsible for circulating blood through the body. Now, this cardiac muscle is actually responsible for circulating blood through the body. And this type of muscle is actually very different than other muscles. Okay, any other muscles from our body, cardiac muscle is very different. You will see why a little bit later. কেউ বলতে পারবে কেন different? How it is different, cardiac muscle?
স্যার কার্ডিয়াক মাসলের টিস্যুগুলো ডিফারেন্স স্যার।
হ্যাঁ বলো, টিস্যু ডিফারেন্ট। আর
এটার উপর কোনো নিয়ন্ত্রণ নাই।
হ্যাঁ, এটার উপর আমাদের নিয়ন্ত্রণ নাই। আরো আছে
স্যার ওই যে 3 ধরনের টিস্যু পড়ছিলাম স্যার, একটা হচ্ছে ঐচ্ছিক, অনৈচ্ছিক, তারপর হচ্ছে
এটা হচ্ছে অনেক
অনৈচ্ছিক অনৈচ্ছিক।
আরো কিছু স্পেশাল জিনিস আছে। আচ্ছা,
স্যার সেল ডিভিশন হয় না।
ইয়েস, এটা হচ্ছে একটা ইম্পর্টেন্ট, সেল ডিভিশন হয় না, খুবই ডিফারেন্ট, খুবই ইম্পর্টেন্ট একটা ইয়া। এনিথিং এলস? আচ্ছা, and these are the main things, okay? বিশেষ করে লাস্টেরটা সেল ডিভিশন হয় না। So you will see one of the major problem, like if you have a heart failure, some of the cell will die, okay? And those cells cannot actually regenerate. Like in case of our other cells, they can actually regenerate, but heart cells doesn't. Acha, so cardiac muscle, these are very different than other muscles and the functions of the heart. Acha, what does our heart do? So heart mainly purpose, the heart actually does 4 things. There are 4 particular things. What is one? Number 1, it collects the blood. It collects blood from all over the body. From all over the body. From all over the body, it collects the blood. Now this blood needs to be refined. Needs to be refined. Okay. Needs to be refined. Why it needs to be refined? These are oxygen poor blood. Okay. These are not oxygen rich, but oxygen poor blood. So the heart collects the blood from all over the body and through veins. Through veins. Okay. Number two, this blood they actually collect, they will pump the blood to the কোথায় পাঠাবে? কিসে পাঠাবে ব্লাডটা?
লাংস।
Yeah.
ফুসফুসে।
হ্যাঁ, it will pump the blood to the lungs. Okay, what does this lungs do? It actually supply the oxygen. Okay, and it removes carbon dioxide from the blood. So when it supplies the oxygen, the blood now becomes oxygen rich through this process. Now I have oxygen rich blood. Okay, so the third process is number 3, collect this refined blood. Collect this refined blood from the lungs. Okay, from lungs, this blood is refined. You will collect the blood. Number 4, pump this refined blood back to the body. Okay, these are the 4 purposes. Okay, and it actually happens every minute, every second. Okay, 70 times, 80 times, it continuously happening. Okay, it never stops. From the moment we born, from the moment, even from the basic level, it is said that the moment we have the heart is the moment we actually were born. Okay, from the fetus. So from that time, our heart starts pumping, and this process is continued until the end. So these are the 4 things. It will collect blood from the body, it will pump the blood to the lungs, it will take the refined blood, and it will pump it again to the body. So these are the 4 things that will happen. And related to the 4 things, we'll get the ECG reading. Okay, in the ECG that we have seen a little bit earlier, so this ECG, we actually mark it in defined states, like this is called PQRST complex. PQRSTU. Okay, so this is the PQRST is one convention. So you will see how this whole process actually relate to the ECG reading. Okay, that we'll understand a little bit later. Okay, understand the readings. We'll go there a little bit later. So these are the 4 things. Any question? Any question? Acha. Now the heart actually have 4 chambers. Okay, 4 chambers. There are 2 atria. You have to memorize a little bit of these names to write the answers, but not very detailed. Only the very important ones. Okay. And 2 ventricles. Okay. Atria, the singular is atrium, so the plural is the atria, and 2 ventricles. Okay. Now the atria actually lies in the top, ventricles lies in the bottom. Okay. So you have this total 4 chambers, 2 atria and 2 ventricles. They actually work together and to perform these 4 tasks. They actually work together to perform the 4 tasks. Okay. Now all of these things, atria, ventricles, these are actually separated from each other. Separated from each other via valves. Okay. So these valves have a characteristic. They are like unidirectional valve, like unidirectional. So they actually allow the flow of blood only in one direction. Okay. They don't allow the blood to flow in another direction. Like the blood can flow from only this direction. If there is a valve there, blood can only flow this direction. The blood cannot flow in this on the opposite direction. Okay. So these valves allow flow of blood in only one direction. Okay. Let's see. Can you see the screen?
Yes, sir.
So this is one of the okay. This is the image of your heart. You can see. Let's start from here. This is the atrium. Right atrium. You can see this is the right atrium. This is the left atrium. So there are 2 atria. Okay, these are the 2 atria. These are the 2 ventricles. Okay, right ventricle and left ventricle. In short, we'll write LV and LV and RV later. So these are the 4 main parts. Okay, 4 chambers of the heart. This is where the blood will be there. Okay, so this is your atria. This is your ventricle. This is your left atria. This is your left ventricle. And you see these ones. You see these things. This is the valve I was talking about. From this pulmonary vein, from veins, the oxygen poor blood will come to the body, to the heart. So this pulmonary vein, blood will enter this right atrium. From this right atrium, the blood will go to right ventricle through this valve. এই ভালভের একটা নাম আছে, এই ভালভের নামটা মনে নেই। এই ভালভ নাম মনে না রাখলেও হবে, সমস্যা নেই। You don't have to memorize everything. So this valve only allows the flow in only one direction, not in the other direction. Okay. So then also from the left atrium, it will go to the lungs. Then again, from the lungs, it will be collected to the left atrium, then to the left ventricle. From here, it will go to this aorta. Okay, we'll see the process gradually. Is this clear? This thing. So if I actually ask these questions like explain the process of the heart, then you can actually draw some of this figure to explain in a rough figure. It doesn't have to be very exact. And you send this septum wall. This actually separates these 2 ventricles. Okay. Just come back here. Let me show one video first. Let's see a video. It will be easier for me to explain later then. Watch this video, then it will be easier for me. Can you listen to the audio?
না স্যার, শোনা
অডিওটা
যাচ্ছে
ক্লিয়ার শোনা যাচ্ছে?
না স্যার।
ভিডিওর অডিওটা শোনা যায় না?
না স্যার। স্যার ভিডিও অডিও শোনা যাওয়ার জন্য শুধু আপনার ওই অ্যাপসটা শেয়ার দিতে
Circulation. Vital. Sustaining alive. Sustaining alive.
আচ্ছা, জাস্ট see the process. Okay.
Neutral, pulmonary, and lungs. A pumping cycle starts when oxygen from the blood returns to the heart after cycle. Blood excess.
Okay, did you see the video?
স্যার।
I will share
Yes,
it.
sir.
I will share it in the Google Classroom, then you can understand. Okay, now let's write it so that so you have 4 chambers, 2 atria and 2 ventricle. Okay, the atria are located in the top, the ventricles are located in the bottom. So you name them as left atria, right atria, left ventricle, right ventricle. Okay, and they are separated via valves. There are 3 different types of valves. You don't have to memorize the names. Okay, and they allow the blood flow in only one direction. Okay, now so from this ventricle at the end pumps the blood into artery. From there it goes to aorta. This aorta actually supplies the refined blood, to the body. Okay, so যেটা শুরু করলাম, আচ্ছা, atrium takes the blood, so oxygen poor blood. Okay. Atrium takes the oxygen poor blood, then something happens inside, we'll see. And at the end, ventricle pumps the blood back into the artery. That is the actually whole process, something that was discussed in the video. We'll see how it works one step by step. Before finishing that, before going there, just to give you some of the names. So artery or veins. What is the difference? What's the difference?
অক্সিজেনের বার ডিঅক্সিজেনের বার ক্যারি করে।
হ্যাঁ, আচ্ছা। This one carries oxygen rich blood, oxygen saturated blood, oxygen rich blood, and this one carries oxygen poor blood. Okay, আচ্ছা। Now, so কি আছে? Okay, now here is the question. Here is the question. So you see this cardiac muscle, we have the cardiac muscle. Okay, it contracts. Okay, it contracts to reduce the volume of atria or ventricles. So you see, previously we saw our atria was here. This was our atria. Okay, this was, let's say, this is the chamber, and here we have this small gap. So this is our atria, this is our ventricle. From atria to ventricle, the blood will flow. This is the right atria, right ventricle. So why the blood will flow from right atria to right ventricle? So this happens because you see the cardiac muscle will contract this atria first. When this atria is contracted, pressure will increase there. Pressure will increase. So when this atria contracts, the pressure increases. So when pressure increases, it creates a outflow through the valve. And just like the valve only flows, allows the flow in only one direction, blood cannot flow back to this ventricle to atria. It only flows from atria to ventricle. Okay, so that actually happens at the start. So what actually starts this process? What starts this process? Action potential. So yeah, I think you have studied the action potential in your previous courses. Ursula?
Yes, sir.
So action potential is like an electrical signal. Okay, you can think of it like electrical signal that will actually kickstart this process. This is the pumping. This process is what we are calling the pumping process. So when you have this difference action potential, this is created, it will start and it will pressurize the atrium. It will allow the blood to flow from atrium to ventricle. Okay, so this is like the contraction. Okay, this is the contraction. Now this contraction is what it relates to the systolic pressure. We measured the blood pressure, right? So this is what refers to the systole. Now the systolic pressure is 120 milligram. Acha. Now what happens after this contraction? After this contraction, it goes to the ventricles. Okay. So it will go to the right ventricle, and this process is called depolarization. Depolarization. Okay. These are some of the terms I'm writing because when we describe the EEG process, this will come again and again. So let me write down the terms first. So we have the atria, it contracts, blood flows to the ventricle, and this process is called depolarization. Now you see this kind of cardiac muscle, have longer depolarization plus repolarization. Depolarization and repolarization. We'll see what is depolarization a little bit later. So cardiac muscle actually have comparatively longer depolarization or repolarization period compared to other muscles. Other muscles like, for instance, skeletal muscles. Okay. And more interestingly, this process, this period or this process can vary vary based on what? For instance, when you are running any kind of physical exercise, like for instance, if you're running, your heartbeat, will it become slower or faster?
Faster.
So when you're running, this process will become faster. So you can see this depolarization or depolarization period will become shorter. Okay. In normal condition, it will become larger. So it can also change. It can also vary. This is different than some other skeletal muscles. Okay. Acha. Now, inside this cardiac muscle, inside this cardiac muscle, the tissues that we have, these are called nodal tissue. Okay. In nodal tissue, we have the nodal cells. And that actually creates this action potentials or other things. So these are the nodal cells. They are different than any other cells of the body. Okay. And they actually regulate the process. Okay. Regulate the heart activity. They regularly regulate the heart activity, and they actually generate this action potential periodically. Okay. So so you see this process, these four processes that we have, now these four processes that we have, it starts from collecting the blood to put the pump the blood to lungs, then take the blood from here. This all starts from here. It starts from the action potential created in the cardiac muscle by the nodal tissue. Okay, and this process continues to happen again and again and again continuously. Okay, since that time actually born, from there to the end, it continuously happens. So any abnormalities in this process, any abnormalities in the process can cause the heart beat to change. Okay, and that is a deformity, that is a problem. Okay, that can actually relate to some other issues, some other diseases. So we'll talk about those ones one by one. So this is the very important process. Okay, this is the fundamental process that we have. Is it clear? Any question? Any
নোডাল
question?
টিস্যুটাও বুঝিনি
নোডাল টিস্যু
নোডাল
বলতে
টিস্যুটাও বুঝিনি
আচ্ছা আচ্ছা, নোডাল টিস্যু বলতে ওখানে আমাদের হার্টের মধ্যে যে টিস্যুটা আছে, যে সেলগুলো আছে, সেটাকে বলা হয় নোডাল সেলস। আর অ্যাকশন পোটেনশিয়াল তো সেলে সৃষ্টি হয়, তাই না? মনে আছে? আমি নিজেও ভুলে গেছি।
Yes, sir.
হ্যাঁ, অ্যাকশন পোটেনশিয়ালটা সেলে সৃষ্টি হয়। সো নোডাল সেলগুলো এই কাজটা করে থাকে। সো ইফ নোডাল সেলস ফেলস টু generate this action potential periodically, that will create one issue. Okay, we'll see in the next class that what kind of abnormalities are there. One of the abnormalities is that action potential is not created periodically. Then there is some there will be some কি বলবো, হার্টবিটটা নর্মালি বিট করবে না। ওকে, ডিফারেন্ট রেঞ্জে বিট করবে। সো দ্যাট ইজ ওয়ান অফ দ্য ইস্যু। এই জন্য আমি নামগুলো আগে বলে রাখতেছি, যাতে করে তোমাদের নেক্সটে যখন আমরা ডিফারেন্ট ইস্যুগুলো নিয়ে বলবো, তখন এই নামগুলো বারবার আসবে। ওকে, আচ্ছা, let's move a little bit forward. আচ্ছা, so you see these nodal cells, they actually regulate this process, and they actually do spontaneously. Spontaneously means we don't control this. Okay, we are not controlling this process. They actually control. They automatically perform this one's regular intervals. Okay, so spontaneously they start with a depolarization. Okay, and this depolarization is followed by repolarization. Every depolarization is followed by repolarization. So you saw this one. Previously we saw this curve. So this is like your depolarization period. This is the peak. After that, you saw before the next peak starts, there is a stoppage time. This is called the repolarization. Okay, so blood goes to the lungs. That process from blood collected to going to the lungs, that is a depolarization process. After that, it comes back. That is the repolarization process. Is it clear? So this is like happening in the right atrium and right ventricle. These things are happening in the left atrium and the left ventricle. Okay, and you see these two processes, they don't actually overlap. They don't overlap. So whatever happens, they cannot overlap. There will always be some delay between these two processes. Okay. So first we have a depolarization, After that, it will follow by a repolarization. Now, this is identified by differentiated by two groups. One is called the SA node, sinoatrial node. So sinoatrial. Number two, FE node, এটাকে বলা হয় atrioventricular. আচ্ছা। So first we have the SA node and FE node. These are called natural pacemakers. Which are called natural pacemakers. Pacemakers because they are actually controlling this heart pumping process. Okay, that's why they are called the pacemakers. So these are two pacemakers. Okay, and among this SA node, this is the main pacemaker. This is the main pacemaker. Okay, because this one sinoatrial node, this one actually the stimulates. This one stimulates the atria. Okay. So if it looks a little bit disorganized, I'm sorry about that. I don't like biology much. I'm just talking about the exact point that you need. Okay, যে বায়োলজি ভালো বোঝে সে আরো বোঝায় হয়তো বলতে পারতো। আমার তো বায়োলজি পড়তে ভালো লাগে না, কেমনে বায়োলজি পাস করছি সেটাও জানি না। So SA node, okay, they are actually the main pacemakers. They stimulate the atria, and the atria, when it stimulates the atria means এই যে একটু আগে বললাম is a contraction. Okay, this is where everything starts, from the contraction. So this is actually happens by this SA node. Okay, they actually stimulate the atria. From there, this process actually continue. Okay, let's come back. Then you have the FE node. This FE node, after a delay, okay, you will see there is a delay. There is a delay period. Okay, and this delay period are important because that's why our analysis will come. After a delay, they actually stimulate the ventricle. Okay, so there are two pacemakers, SA and FE node. And through this delay, what will happen in this delay? This delay gives time to atria to empty. Okay, so from atria, blood will flow to the ventricle. So it will take some time. So if you do it, if the SA node or FE node are actually fired at the exact moment, then it will not have the time to empty its chamber. So after SA node, the atria will contract, blood will flow to the ventricle. After that, the ventricle will, from the FE node, a ventricle will stimulate. So from there, blood will go to the lungs. Okay, so there is a delay there. That's the process. Okay, so are you following?
Yes, sir.
Achha. Now, this FE node, this is slower compared to SA node. Why slower? We'll see in the ECG process. In the ECG, this one is very sharp, but the repolarization is actually has more time. This process, you will see this one has more time. This is very small time, comparatively small time. So the FE node process is much fast. The SA node process is much faster. FE node is a bit slower. Okay, it takes some time. Okay. And any variation in this process will cause the abnormality. Any questions so far? Achha, let's see. So you have the oxygen poor blood. Okay, oxygen poor blood will enter the right atrium. Okay, you saw in the figure, from the right atrium, it will enter first. Okay, and this happens due to the depolarization by the sinoatrium node, SA node. Okay, now this right atrium, this will contract and force the blood to the right ventricle. Okay, Are you following?
Yes, sir.
So it goes to right ventricle. From this right ventricle, this will be pumped to the lungs. Okay. It will go to the lungs through the pulmonary arteries. Pulmonary arteries. Okay. So in this lung, the blood will be saturated with oxygen. Okay, blood is rejuvenated with oxygen. So now you have the oxygen-rich blood. Okay. At the start of the process, you had oxygen-poor blood. Okay. After it goes to the lungs, you have the oxygen-rich blood. All these things happening in the right side. Okay, right atrium and right ventricle. From this right ventricle, from here, this oxygen-rich blood from the lungs, it will go to left atrium. Okay, and this is the repolarization process. Left atrium, then it will go to left ventricle. And all this process will only flow in one direction because there are valves there. All the valves are unidirectional. It only allows the flow in the only one direction. So left atrium to left ventricle, from left ventricle to aorta, and this aorta will supply blood to the body. Okay, this is the entire process. Are you following?
Yes.
So also,
একটু টাইম দিন স্যার, এটা লিখুন,
হ্যাঁ,
একটু উপরে তুলুন।
okay. So you see, this is the entire process that is happening, and these things is happening every day, every second, continuously happening. Okay, every minute it is like 80 times a minute, I think. So this process continuously happening. This is only one heartbeat. This whole process equivalent to only one heartbeat. Okay, and these things actually happens around like 100,000 times per day. Okay, Achha. Now, so this is our process, the actual process of heart functions or the heart beating process. Now, how we can actually record it, how to measure it, things
স্যার
like that. হ্যাঁ, বলো।
স্যার অ্যাভি নোটটা কোথায় ইউজ হচ্ছে, মানে এই প্রসেসের কোন জায়গায়?
এসএ নোড আসতেছে হচ্ছে সবার প্রথমে। এসএ নোড আসতেছে যেটা হচ্ছে সবার প্রথমে তোমার ইয়াটাকে সৃষ্টি করতেছে। এভি নোড আসতেছে হচ্ছে তোমার এই ভেন্ট্রিকল অপারেশনটা যখন শুরু হয় এই জায়গায়, এই জায়গায় রাইট ভেন্ট্রিকল টু লাংস, এই জায়গায় আসে। ওকে, after a delay it from the ventricle to lungs, it force the blood. So that's the AV node. Actually, now this process first recorded in 1903. Mr. Wilhelm Einthoven, he was the first to record this. Okay, and he recorded these readings in paper. Okay, now so this process, how to record this process, this is process recorded using electrodes, okay, placed on the skin of your body. Okay, and you see this during this process, the depolarization or repolarization that is happening, the repolarization is what is actually creating the potential difference. Because of that, the contraction is happening. The contraction is forcing blood from one chamber to another. So that actually something we can measure it. Okay, something measurable. So this process generates, so this repolarization generates the potential difference. This one generates the potential difference. Okay, and that is what we are measuring through these electrodes. Okay, so electrical activity. And if we try to put it here, it looks something like this. Okay, then it goes here and comes back, then like this. After that, this process actually repeats. Okay, so this is your called P. Okay, This process is marked by this. This is Q, this is R, this is S, this is T, this is U. Sometimes U is not mentioned, so either 5 or 6. These are the peaks, PQRST. Okay, so this PQRST is RST. Usually, this is the 5 peaks. So this is the 5 points that is utilized to actually measure the measure an ECG wave. Okay. So the process starts at P. Why do you have the depolarization of the atrium? Depolarization of the atrium. That's where the process starts. Okay. Now, this P wave, as you can see here, this is like starts for 90 millisecond around. Okay. This time is very important. Millisecond means you are measuring it with respect to time. Okay. And this exact time when you have, this is actually very important because from this one, we can actually diagnose different conditions. For some conditions, you will see this wave will become very much faster. When it is faster, that means there is something wrong with it. If it is slower, that also means something wrong with it. If it is not very symmetric, then there is another issue. So this measurements, this time measurement is one type of measurement that will do the time domain analysis. Achha. So this is the P wave, and this lasts for around 90 milliseconds. Okay, and so this depolarization of that atrium means it is going to contract. Okay, and through this contraction, you have the field of ventricle. You have the ventricle filled up. Okay, and the voltage, you can see that R wave has the highest voltage. Here you have the voltage. Here you have the voltage. The R portion has the highest voltage. The P voltage is lower than that. So we can also measure it, the amplitude. The amplitude is around 2.5 to 10 to the power minus 4. Okay. Acha. Now, are you following? বোঝা যাচ্ছে আমার কথা?
Yes, sir.
So you can see
90
from
মিলিসেকেন্ডে কি বলছেন? স্যার
এই যে
90 মিলিসেকেন্ডে কি বলছেন?
এই যে P টাইমটা P ওয়েভটা কতক্ষণ আসলো? The time it takes to have this P wave. So this P wave means you have the contraction. That is what you are actually reading. And the contraction is subsided. So contraction subsided, the P wave is actually done. Okay. Then the next ventricle process will happen. And you see, after this contraction, again this P wave again reappears. So there is a time difference from this P to P. Okay, there is a particular time difference. And this is supposed to be like symmetric or periodic. Okay. Now, so from P wave to this is called QRS complex. Okay, this portion, this entire portion, this magnitude that you have like this is called a QRS complex. Okay, now from P to QRS there is a small time difference. Okay, some quiet time because my drawing is not accurate. There is a small quiet time because P wave finishes, then you have a small time, then the QRS starts. So a small delay. There is a tiny delay there. If you look at the exact ECG, we can see those. You can see those things. So now then you have this QRS complex. What do you have in the QRS complex? This QRS complex is like 80 milliseconds. It's smaller than the P portion. The P portion, this QRS portion is much smaller compared to a little bit smaller compared to the P portion, and it lasts around 80 milliseconds. Okay. I'm not sure about the exact value of these things. You have to search the wave. What is the standard value that is considered in like biomedical process? Okay. And this one is the highest one. So this highest range goes for 1 millivolt. Okay. This is the maximum that you actually read. So this one is the peak. Okay. And again, the peak will appear. And we can measure this peak. And from this peak, we measure the periodicity of the ECG measurement. So from this peak to this peak, the time that you have from this peak to this peak, that is how we define the periodicity of the ECG. Okay. And this is supposed to be periodic. In this time point, this is supposed to be periodic. So if it is shorter, it can if the periodicity is shorter than the usual ones, that you can say there is some disease associated with it. Okay. Also, if you are like exercising, you are doing exercise, that will also lessen, that will also reduce. Achha. So based on this R values, the R values, the point where R is actually coming, based on that, we actually measure the periodicity. Periodic. Okay. That is where we measure. Achha. Where does this QRS complex coming from? Achha. This QRS complex happens when you have the ventricular contraction. Ventricular contraction means when there are some other things like other values like Purkinje fibers, there are other process, অত ডিপে যাচ্ছি না, আমি যতটুকু বুঝছি সেটাই বুঝাচ্ছি. This one happens when you have from the ventricles, the blood will be pumped to the lungs. Okay, at that time we will have this maximum one. Are you following? Are you following? So from the atrium, you have the P wave. The atrium contracts, blood flows to the right ventricle. From the right ventricle, this is supposed to, the right ventricle will contract and the blood will flow to the lungs. And that time you have this QRS complex. Okay.
তা 1 মিলিভোল্টটা কি পিকের ভ্যালু ভোল্টেজটা?
হ্যাঁ 1 মিলিভোল্ট পিকের ভোল্টেজটা আমি এক্সাক্ট ভ্যালুগুলো একবার চেক করে তোমাদের বলবো, এখন আমি শিওর না এটা। It is
উপরে যে
supposed-
আরেকটা আছে 2.5,
হ্যাঁ এটা এটা কত হয়, মিলিভোল্ট করলে কত আসবে?
0.25
আমি
মিলিভোল্ট।
হ্যাঁ হ্যাঁ 0.25 মিলিভোল্ট। আচ্ছা, সো দিস ইজ লাইক 0.25 মিলিভোল্ট। এক্সাক্ট ভ্যালুটা আমি আরেকবার একটু শিওর হয়ে দেখাবো, আর শিওর হয়ে দেখবো এখন। ওকে আচ্ছা, সো আফটার দিস PQRST you have a T wave. Okay, now this T wave refers to the repolarization. Repolarization. Achha. So what happens in the repolarization? In the repolarization, you see after the after blood goes to the lungs, then it comes to from the lungs, it comes to the left atria. Okay, the left atria becomes fills up. Okay, so the left atria fills up. That process actually referred to the T wave. Okay, that is the repolarization. So this process, after this PRS2, this process, this is actually your repolarization step. The first you have the T wave. Okay, now this repolarization, like I said a little bit earlier, repolarization takes more time than depolarization. Okay, repolarization takes much longer. Okay, it is much slower, and this is referred to the SV node, okay, sinoventricular node. Okay, so the atrium fills up and the blood comes back to your left atrium, then to your left ventricle. Okay, acha. So the thing is, the depolarization is longer than your depolarization. Okay, so this is like more smoother. Okay, smoother means you see there is a smaller gradient. You see this one, this is like a very fast sense. Okay, but this is much smoother, so the gradient is smaller. Okay, this has a very large gradient compared to this one. This is large gradient, this is a smaller gradient. So this is one type of measurement that you can do in analyzing the signal. Okay, and also the amplitude is less than the QRS complex. The T wave has less amplitude than QRS, but higher than P, greater than P. Yeah, P এর চাইতে বড়, but T wave এর ক্ষেত্রে P এর চাইতে বড়, but R এর চাইতে ছোট হবে. It will be larger than P, but smaller than the R region. Okay, this is your T. And the T wave is followed by the U peak. Okay, this is also the repolarization step, but sometimes it is not considered. It is not always considered as a standard. So normally the 5 PQRST, this is PQRST is also all or considers the standard approach. Okay. Acha. Any question so far? Any question? Okay, so this actually refers to
ইউপি
ইউটা
Last
ইউটা
UP
হচ্ছে
টা কি?
রিপোলারাইজেশন কন্টিনিউস করে তোমার অ্যাট্রিয়াম থেকে ভেন্ট্রিকুলারে চলে যায়, তাই না? লেফট অ্যাট্রিয়াম থেকে লেফট ভেন্ট্রিকল, সেখান থেকে আসতেছে অ্যাট্রিয়া। এই যে এখানে যে কাজটা হয় সেটা হচ্ছে ইউপিকে চলে আসে, বাট ইট ইজ সামটাইমস নট কনসিডার্ড এজ এ স্ট্যান্ডার্ড। স্ট্যান্ডার্ড বলতে এটাকে সাধারণত কনসিডার করা হয় না, কারণ ওটার ইয়াটা খুব ছোট, মানে হচ্ছে টি এর পর এই যে এই পিকটা সাধারণত খুব স্মল হয়, ওই জন্য বোঝা যায় না, ওই জন্য ওইটাকে কনসিডার করা হয় না। মেইনলি পি, আর অ্যান্ড টি, এই তিনটা হচ্ছে মেইন মেজারমেন্ট ধরা হয়। ইজ ইট ক্লিয়ার? পি, কিউআরএস কমপ্লেক্স অ্যান্ড টি। আচ্ছা, okay, so this is actually our ECG reading. Okay, so as we started from here, so as we started from here, the first thing is that we need to understand the biological process, how the heart functions. Okay, I gave you a summary here. I discussed a little bit of summary. So read I will provide some videos, 2 or 3 videos. Try to watch them or use some. If you don't understand it properly, always definitely read the book. Okay, so I don't understand this process entirely perfectly for myself, so you can also read some book to understand the process clearly. Okay. Then you see how we actually measure it. You can see how PQRS actually comes from, where each process, how everything comes from, and how the signal processing part we'll discuss later. After we cover this entire portion, we'll talk about signal processing later, because this is standard for every signals. So then understand the readings. You have understand the readings, what this PQRS everything actually represents. Okay, so the abnormalities that we have, we'll discuss in the next class. Before that, so whatever you have, whatever I have discussed now, but definitely read the book. Read the book or some other articles, definitely. Otherwise, this will not be enough. Okay, I just discussed in very briefly the process. Acha. So there are a few other things. For instance, the electrode. How do you place the electrode? Electrode placement or measurement. You see the Einthoven, the original who started Einthoven, Einthoven. So he's had the old standard. In the old standard, there he used to use 3-point measurement, 2 arms and leg, one in the leg. So left arm, right arm, and one of the leg. Acha. So the potential difference between these two, these are actually measured. Okay, like this way. And in the new standard, after these 3, there are 6 other electrodes. 3-point means 3 electrodes are placed, 2 in the 2 arms and 1 in the leg. New standard, 6 other points, that means 6 other electrodes are used around the chest. Okay, around your chest. These are marked as from V1 থেকে V6, V1 to V6. Okay, these are placed around the chest. There is like a standard how we actually where exactly to place those things, and that is not important for you to know. Also, you can add some 3 others. Okay, so in total, like we use 9 or 12, I think 9 or 12 electrodes, 9 or 12 electrodes to completely measure this kind of ECG, completely take this ECG reading. Okay, through this measurement, we take this ECG reading. You can see, I will try to place some image or video to show you where exactly how we actually place these electrodes in the body to actually take these readings. And these electrodes, they are like non-invasive. For if you want to measure more clearly, it can also be invasive. Some other ways you can also make them invasive. Normally we go for non-invasive. Okay, and these all electrodes, when we actually take the readings, they are measuring the electrical signals, and these are connected to amplifier, also some filters. In the later, when we discuss the signal processing part, how we actually process this kind of signals, we'll see how these things works. Now, as for the amplifier, you see the signal that we take, we actually use differential amplifier. differential amplifier. That means any voltage difference between 2 points are multiplied. Okay, right? Voltage difference that is actually multiplied. Also, common mode rejection. So if anything is common between the two, that will be rejected. So like this way. So these electrodes are connected to amplifiers. Then we actually get some filters. We filter some of the noises. Then we get the reading that we actually see in the ECG machine. That is where we actually get the reading from there. Last one, so heart rate. So as you can see, this heartbeat process, this is actually very important. The heart rate is the most indicative measure. Okay, most indicative measure, whether it is normal or abnormal. If anything abnormal in the heart rate, that is there is something wrong with the your cardiovascular system. Okay, so this is happens 70 to 80 times, I think 70 to 80 beats per minute. Okay, so that's like 100,000 times per hour, 100,000 times per day, sorry. So that's like 40 million per lifetime. So, and you have this P, QRS, T. So that's your QRS, that's your systole. That is your diastole. Okay, that's where the pressure comes. Achha. So that's your heart rate. And when you actually measure this one, this is like when you record it, this is like 0.8 second, okay, on ECG. And based on this time, we can actually take some other measurements as well. Whether how we actually measure these signals in the time domain, we'll see in the next class. Achha, any questions so far? Any question? So today, okay, so let's finish it. So today you see how, first of all, for this one, how the heart functions. Okay, the function of the heart. I have discussed in brief. So in the video, you will see some other things as well. So try to understand the process, how it functions, how it is related to ECG reading, how you can actually relate the process to the ECG reading. When you have the atrial contraction, you have the P. From atrial to ventricle, then ventricular contraction, then you have the QRS complex. So like this way. So how different activities of the heart actually relates to the ECG reading. Okay, try to understand the process related to ECG, then understand the reading. Understand how the readings actually indicate, what the P indicate, how the QRS indicate, things like that. We'll discuss it more about these readings in the next class in more details. Okay, any other question? Any question? Okay, if not, then let me finish this one. You can write your student in the comment.